Right, hey Roy, good to see you here. Now I'm still waiting for it to come up on my other screen. Hopefully it will now. Oh yep, there we go. Okay, cool. Now I've got two windows open so I can see the chat now. Roy, how are you getting on with the harder work that I gave you, with the delta work? How's it going? Type me in a comment. I'm just also trying to get a feel for how bad the lag is. So guys who are just joining now, just come on and say hello. Welcome back. Another day of Year 9 Maths. Hi Torben. Hey Nikki. Well done guys. Nice to see you here. So I'm just chatting with Roy in the chat about the work that he's doing. But for you guys who've just got here, hi Zach. Nice to see you. Hi Kieran. How's it going out there? Tell me how your day's been. Zach, you haven't been doing my my photo competition. Okay, so my tutor group are doing a photo competition, and they need to guess whose animal picture is the cutest, who belongs to who. Anyone else doing anything good like that? No? Alright, so here's what we're going to start off with today. Some questions like this. So, Torben, and Nikki, who else is here? Zach, Kieran. Yep, cool. So, we know that x squared means x times x, right? And we know that x to the power of 4 means x times x times x times x. Just one sec, guys. Fletch, can you just be a little bit quieter while I'm streaming? Sorry, thanks. Sorry, my helper is undoing the dishwasher for me, which is all very good. Hope you guys are helping your parents out a bit. Right, so we learnt what we can do when we've got things like this. So x squared times x to the power of 4 will equal what? So type your answer in. Let's see, what have we got? Yep, so guys, type your answer in. Sorry, the lag is quite bad today, but that's okay. We'll get there. Got lots of people not coming onto the live feed. Maybe it's not worth it. Don't know. Theo's not here. Just message everyone. Just sending an EP message out. Right, so let's have a look. What have we got? Yep, that's right. So, Jackson, it is probably best if you are on here to make sure you're getting the hang of everything, because today I'm going to do division. All right, so we're pretty good with that being x to the power of 6. So, Torben, Kieran, Roy, you guys should disappear and come back at 3 o'clock. Zach, you might want to come back at 3 o'clock. I'm not sure. I'm going to go much faster through it at 3. I'm going to go slowly through it now. Jackson, I think you're probably in between, so you're better off to stick around. I'm not going to be that long today, I promise. Okay? But we've done expressions like that, right? So we know that if we've got the same base, we can just add the power. So if I've got a to the power of 4 times a to the power of 7, that will be a to the power of 11. Now, if I've got 2a to the power of 4 times 2a to the power of 7, that will be 2 times 2 is 4, so 4a to the power of 11. What we're going to look at now right? So what we're going to look at now is how we do division. So let's look at ones like this, x to the power of 7 over x squared. Right, if I write that out once, this is what I'm going to get. I get x times x times x times x times x times x times x divided by x times x. And when I simplify, this is what happens. I get x to the power of 5. Okay, Quinn, it's fine that you're late, but come back at 3 o'clock, please. So just hop off now and come back in 25 minutes, because I'm going to go through this pretty thoroughly to start us off. Hi Arthur, come back at 3 o'clock. We're going to do we're going to do this stuff quickly then, and then we're going to do some extension work. Okay, so the rest of us who are here, we're just going to take it a little bit more slowly. Let's look at 3 examples. So a to the power of 6 over a squared. Simplify that one. A to the power of 7 over a to the power of 3. Let's try those. Just a sec. So I'm going to do 2 for you first. So we're not going to do this for much longer, but we know that that means a times a times a times a times a times a. That's what a to the power of 6 means. And we're dividing it by a times a. So these are common factors, right? And they simplify, just like when we were working with simplifying fractions. So we're left with a to the power of 4. With a to the power of 7 over a to the power of 3, it goes like this. A times a times a times a times a. 1, 2, 3, 4, 5, 6, 7 divided by a times a times a. So when I simplify that, these go, and these go, and I'm left with a to the power of 4. So let's look for a pattern. Well, I've got 6 here and 2 here, and we end up with 4 here. Here I've got a to the power of 7 and a to the power of 3, and I end up with a to the power of 4. So let's see if we can shrink that, and we'll try a couple more. This time you're going to try them, and you're going to type the answers into your YouTube chat. So let's try b to the power of 10 divided by b to the power of 2. Number 3, I'm just trying to make it a little bit bigger. So number 3, c to the power of 8 divided by c cubed. F to the power of 7 divided by f squared. And g to the power of 12 divided by g to the power of 6. So do those, whoever's out there still. Nikki and Jackson, I know you're there. Let's see who else is here. Zach, are you still there? Drew, good, awesome. Who all is here? That's it, Jackson. Which one's that first one? It's not going to be B5. So let's have a look and see what we've got here. Come back up to this one here. When we had a to the power of 7, we could write out a times a. Up on this line here, we had a times a times a times a 7 times, right? And then a cubed was a times a times a. So when we simplify, we've got common factors, right? So this a divided by this a is 1. And this a divided by this a is 1. And this a divided by this a is 1. So that leaves me with this block here, a times a times a times a. And that gives me 4, right? So I had a to the power of 7 over a to the power of 3 will be a to the power of 4. So try and look for that pattern with what we've got here. We've got b to the power of 10 over b squared. Right? So what I end up getting is this, b to the power of 8. So that's right, Nikki? Yep, you've got it. Okay, so now try these ones. When we've got the same base, we can just subtract the powers. We don't have to write them all out every time, because that would be really, really painful. So b to the power of 8 is the answer here, because I've got b to the power of 10 over b to the power of 2. Yep, that's it, Nikki. Well done. That's good. Hey, Fergus. Right, Nikki, you got the hang of it really well. What's number 4? Yep, that's right. Fergus, just jump in here. We're doing some division stuff. You probably want to watch this a little bit and then come back at 3 o'clock as well. Okay, so that's good. So Jackson, are you out there still? Can you see what we're doing? So this one here is going to be c to the power of 5. This is going to be f to the power of 5. And this is going to be g to the power of 6. That's it. C to the power of 5. Jackson, you've got it. Right, okay, so a few more like that. Getting really fast now. X to the power of 9 over x to the power of 4. Y to the power of 10 over y to the power of 2. A to the power of 6 over a. And a to the power of 7 over a to the power of 6. Right, off you go. We'll call those 1. Let's see the order. 1, 2, 3 and 4, and when you're ready, guys, just type in your answers for me. Yep, Jackson, you've definitely got it now. Nikki, you've got it now as well. Fergus, you should be able to pick that up pretty quickly. Drew, are you still out there, or have you hung up the phone? You might have hung up the phone. How are we going? Yep, Drew, you there? Good, okay. Okay, Nikki and Jackson, right, guys? Yes, answer these guys, please. Yep, answer them. Yep, then we're going to get a little bit harder after this. That's okay, Drew. You guys are doing really well this week with all of the IT. I'm going to send a questionnaire out tonight to see how you're getting on with all of that stuff. And so just if you can charge it or find a charging cable, just plug it in now. Let's have a wee look. Yes, Jackson, awesome. Right, x to the power of 5, well done. Okay. Right, x to the power of 5. Nikki, what have we got? The first one. Yep, good. Number 2, y to the power of 8. Lovely. And then number 3, a to the power of 5. Now, what's the next one? This one here is a to the power of 1. But we don't write a to the power of 1 because that's just the same as a. So that's good. That's good on those. Fergus, are you out there or have you disappeared? Okay, so now we're getting the hang of division and multiplication. We're going to do tiny bit of revision before we go on. So we've done numbers, we've done coefficients and multiplying, and the next thing we're going to learn Yep, so Fergus, if you're finding the introduction to factorising impossible, you need to watch yesterday's live stream. Hey Jules, how you going? Right, so Fergus, go watch yesterday's live stream because factorising is a unistructural skill. We've got to get that figured out. Also, if you're finding it impossible, go and watch the basic skills videos that we've posted on Google Classroom. Okay, so fine if you go and do that now for 15 minutes before you come back for the harder stuff. All right, so go watch the basic skills videos. The playlist is on Google Classroom. Okay, so those revision questions there are from multiplication that we did, I think it was yesterday or maybe the day before. So 6c cubed times 5c to the power of 5. So what do I do with questions like this? Right, so have a crack at those and then chuck your answers in. Yep, Jackson, you're remembering that really well. Well done. All right, Fergus, if you can't find that video, you're not looking in the right place. So it's on our Google Classroom, and there's a whole playlist with every basic algebra skill that we need for Year 9s. So go do that. Right, Jackson and Nikki, are you there? Jackson, you've got these really well. That's great. So that one's 10b cubed. Cool. Yep. Yes, Drew, well done. 12a to the power of 5. Fantastic. Okay, Jackson, 30c8. You guys have really remembered this very well. So that's 12a to the power of 5, and this one's 10b. Now, the thing to watch with this b is that this is b to the power of invisible 1, right? So Jackson, you got that. Nikki and Drew, hopefully you got that too. So this is going to be 10b to the power of 3, and this one is going to be 30c to the power of 8. Good, so that's multiplication. So the next thing we're going to do is something similar with division, right? So let's think about how this is going to go. It's going to be the same exact idea. So number 4 and 5, 30x to the power of 10 divided by 5x to the power of 3. So think about how we did the numbers when we were doing the multiplication, and then this one, 49 y to the power of 12 over 7y to the power of 3. So just let's have a look at how they go. I'm going to model those two for you first, and then I'm going to give you some. So here we look at the numbers first and we look for a common factor. So 30 divided by 5 gives me 6, and then here I've got x to the power of 10 times x cubed, so that's x to the power of 7. This one here, looking at the numbers, I'm going to have 7y to the power of 9. I'll shrink those a bit so that you've got those ones left up there, and now we'll give you 3 to do. Jules, you're very welcome to stay now for the revision. That's all good. Probably a few more people who should be doing that. So let's try some, I'll give you a couple of easy ones first. I'll put some over here as well. There you go. So try 6, 7, 8 and 9 while you're sitting there. Yep, no, Jackson, you're forgetting about the invisible number 1. And you're forgetting that what we did here, look what I've done here. I've divided 49 by 7, right? So you're not doing the right thing to your numbers. Nope, not yet. You're not there yet. Right, so look what I'm doing. I'm saying 49 divided by 7 is 7. So down here, I need to be looking for common factors here. What's 12 divided by 6? And with the powers, the rule is that I subtract the powers. Okay, so we do our division, our common factoring on the numbers, and we do our subtracting the powers here. So try again. Nikki and Drew, have a go. I don't mind if you get it wrong. Just give it a shot. Jules, did you have any trouble getting into the channel? Just gonna send the link out. Oh, Toby's here. Cool. Hey, Toby. And I'm just waiting for Josh to join us because he's had some trouble getting on. Toby, did you have... Roy, what do you mean you're from the EP? Yeah, of course you can stay here, Roy, but it's fine. You're welcome to stay here. Just waiting for you guys to have a go at these. Right, Nikki, what do we got? 12a squared. Well done. Not 12a squared. Yes, 2a squared. I can read it right. So, 2a squared, right? So I'm dividing the numbers and I'm subtracting the powers. This one is going to be 5b squared, right? Now, what about this next one here? Not as easy, right? It's going to be something with x to the power of 4, but here I have to divide out my common factors. So this is lots of practice. Lots of practice here at fractions. So the common factor here is 6. So we take the 6, divide the 6 out, and we get 3 and over 4. So we end up with 3 over 4 x to the power of 4. This one here, we've got an 8 common factor and an 8 common factor. So we've got 4 over 3. And we subtract the powers and we get x cubed. Okay? Right, now hopefully that is enough practice that you want to go and do your EP. Okay, Jules, why is it squared? Which question for 6 and 7? Well, it seems to me that you maybe don't come in at 3 o'clock because that's what I've gone over right at the start of this. Why is it squared? Because I'm going to subtract the powers. So what I want you to do is to watch, Jules, I want you to go back to the start and watch the stream because I went through that really, really slowly. Okay? So the stream will go up, or you can even rewind it now and you can watch the start. Okay, right, let's just check for understanding with a couple of last ones before you go. There you go, just 4 left, and then you can go and do some education perfect. Okay, anyone just joining in now, you can just do those 4 questions that are on the screen. Hi, Jordan. Jordan, you've missed the whole stream, so you're going to need to go and do a rewind and watch from the start. Okay, because we started 23 minutes ago. Yep. Hi, Jordan. Okay, yep, Jackson, you got this down really well. That's great. So 7y to the power of 4. That's good. Right, what about this next one? What are we going to do? Well, we're doing numbers first, right? Numbers first. Yep, that's right, Quinn. Numbers first in here. What do we get? Come on, someone, type it in. Yep, good, Nikki. That's it. How are we getting on? Yep. Okay, so this next one very quickly is going to be this. I've got a 4 here and I've got a 12 here. So that simplifies to give me a 3. And here I've got x to the power of 10, x to the power of 8. So it's going to be x squared divided by 3. This one here is a slightly harder one. It's got a common factor in here of 4. So that's going to be 4 and that's going to be 5. This is x to the power of invisible 1. So I end up with 4 over 5x cubed. Now this next one is going to be, this is going to be divided by 5, and so this is 1 and this is 5. This is a harder one. So here, this is going to be, I've got x to the power of 5 here, but I've got x to the power of 6 down here. So I end up with 5x in the denominator and just 1 here. Now if you find that one a bit hard to get your head around, then don't stress that today. That's definitely not a unistructural question for year 9s, but it is a good one to be able to understand, right? The basic rule is I always look at my numbers for common factors, and then I look at my variables, and I'm always working with things with the same base. Alrighty, guys. So that's maths for today for you. Keep going on the Education Perfect. Every single person who's coming on these live streams is doing a good effort with both the live streams and with the EP, so keep going. Well done for your first day of lockdown, and fast people, we're going to do some harder stuff in about 3 minutes. So just stay there while I go and get myself a drink of water and print a couple of things out. Okay? Yep, Drew, you can go, and Jackson, you can stay or go. I don't mind, Drew. You guys are all welcome to stay, but you're also welcome to go. So, Torben, welcome back. And who else is coming on? Who else is here? Let's see. I just need to print one thing, guys, to my upstairs printer. So I gotta go do printing. Just give me a second, because there's a cool thing that I want to do with you today, but I can't on this screen and that one. It's taking ages. Where is it? No, that's not what I want. It's a thing from the enrichment classroom. Roy, hello, welcome. My computer's going a bit slow. So just sit there and talk amongst yourselves, talk nicely. We're in public forum. Tell me one cool thing that you've done today while I'm trying to get my computer to work. just want to print something out for us. Where's it gone? This is what I want. This is a thing from my favourite guy in the UK, who is a man called Don Stewart. I've talked about him a bit before. He has done a PowerPoint that I want to use for us. It's not there. Here it comes. Right, I'm just going to go print this. Hi, Ben. How are you? Right, guys, no one's talking. Tell me something cool that you've done today. Hi. Right, just having a short printing break for me. So far, Quinn has patted his dog. That's nice, Quinn. I'm sure the dog liked that. In fact, I'm sure walking the dog is quite challenging at the moment. Have you taken the dog for a walk yet? Or not yet? Sleep. Hi, Mac. Right, Fergus, I think you should probably go for a walk or a run. Mac, I am going to be going very fast at 3 at 2:30. Fast in line the lives and what's cool. And stream. I'm wanting up. Okay. How much swim? I have got to guess your number. Right? So I'm going to do this through typing into the chat, and I don't want you to type anything. Don't type your number in till I say to. Right, I want you to take your pen, think of a number, write it down. Okay, just tell me if you've done that. Just think of a number and write it down. Times your number by 4. Write this down. Okay, I'm going to say all of those instructions now as well. Right, so think of a number, write it down, times it by 4, and then add 1 to that number. And then times all of that by 3. And write that down and call it A. Okay, so you can just say yes when you've done that. Good, good, Fergus. Good. Okay, here comes the next lot of instructions. Take your original number, right? Take your original number, add 2 to it, times this by 2. Write it down and call it B. Okay, good, Theo, right? Great. Okay, so now I am going to guess some of your numbers, right? So this is what I want you to do. Right, I want you to write down in the chat what A plus B is, right? So Ben, for number B, okay, right, 595. Quinn. Right. Let me do some magic. Kieran, don't show me the two numbers. Don't show me the two numbers. Right, it makes it less impressive when I'm doing my magic. Okay, 76, 49. Let's see. Whose am I going to guess first? I think I'm going to start with... Hi, Arthur, you've missed our fun game. Right. 49. Fergus, your number was 3. Okay. Kieran, let's come back to you because I think you've done something wrong. But that's okay. Whose number was 84? Let's see. 84. Was it 3? Was it 3 or not 3? Jules, I just want your A plus your B. Okay. Okay, did I get it right? Fergus, was I right for you? Was your number 3? Quinn, I have a prediction. Quinn, a prediction for you is that your number was 42. Right, Roy, your number was 75. Jules, is that 7,516? Oh, it's 91. 91. Okay. Jules, your number was 6. Who have I missed out? I've done Roy. Torben. Ben. Ben, what did you do? Oh, Ben, 77. Your number was 5. Right, how am I doing? Am I good? Okay, what did I do, guys? It's not magic, right? It's algebra. Yeah, I got it right. It's not that I'm a magician. It's that I can do some algebra. So what I want to do with you guys today is to start off with looking at how we can write some expressions. And then we're going to do some extension stuff. So I want to show you where the extension stuff is that we want you to do, because this is a really cool task that we've put up on the enrichment website, and it's over here. Okay, why is that coming up like that? Right, if you go into our Google Classroom, you're going to see the screen here. So remember that as well as our Year 9 classroom, there's this whole Google Classroom called the Year 9 Enrichment Classroom. And it's got heaps and heaps of awesome stuff in it. So I want to show you today what you could be doing in here while you've got more time, because I'm seeing some of you saying that you're bored. And so this is a brilliant time to be doing some maths. Okay? And we've put a few extra things in here. The first thing we've put in is a whole lot of extension tasks on all of the Year 9 algebra work. And there's one that I'm going to do today, which is on expanding. And it's called expanding proofs, right? So I want you to write down in your book that you're going to go and do that as extra fun work later on. You don't have to, but I think you'll enjoy it. So the sheets look like this. We have to prove that things are always multiples of things. And that very first one there is the guess a number that we just did. Okay, so we want to prove that this is always a multiple of 7. So let's look at how we do that. So let the number be n, right? So if I want to times a number by 4, what does that get me? Well, it gets me n times 4 is 4n. And then I add 1 to a number. Did I not do Nikki's number? Oh, hang on. What was Nikki's number? I think Nikki had a mistake in his number. Hang on, Nikki. What number did you say? Where are we? Nikki. Oh, I didn't see it. Oh, hang on. Nikki's number is 288. 288. Right, let me do my magic. Oh, Nikki, something's wrong with your numbers. Okay, so you've picked a weird number. I'm not hacking. Right, so let our number be n, right? So we started with a number and we times it by 4. That got us 4n. And then we added 1 to that number. So our number is 4n plus 1. Okay, if I want to multiply that number by 3, what do I have to do? Just have a think, right? So I've got my number n and I've times it by 4 and then I've added 1 to that number. If I want to multiply the result, all of that, by 3, I have to put it into brackets and I get this, 3 times 4n plus 1. And that was my number A. And then I said start again with that number, right, n, and add 2 to it. So we add 2 to it, and then we times that by 2. So we're going to put that in brackets, and we get 2 times n plus 2. That gives me B. And I told you to add A and B together. So what I want to go back and look at now is all of your numbers. And I want to look at something cool in them. Now, Nikki, your number didn't work. But the rest of us, here's what our numbers were. So I'm just going to go back through that chat, and we're going to write down our numbers and see what we've got. So Fergus, we've got 49, right? Torben, I don't know what the 76 was. I think it was meant to be 77. So Ben's number was 77, right? Kieran, I didn't do your number because there was something wrong with it, right? Nikki, your number was 288, and that also didn't work. But Roy's number worked. It was 1057. Okay? And Quinn, your number was 595. Theo, your number was 84, and Jules, your number was 91. I want you to look at these numbers here and see what they're all obviously multiples of. And these ones are also multiples of it. So when you've seen it, what are these multiples of? Because this is part of what I was doing. Right, let's see. What do we got? What have you noticed? Mac, this live stream will be finished in about 10 minutes. Okay, so all of these numbers are multiples of 7. Right? They're all multiples of 7. And what we want to look at today is how we can prove that when I do this number trick, whatever I end up with will be a multiple of 7. So let's see why it works. Well, it all comes down to expanding brackets. I've got 3 times 4n plus 1, that was my A, and then I'm adding 2 times n plus 2. That was my B. So, what do we get? Well, from the first expansion, we get 12n plus 3 plus 2n plus 4. That gives me 14n plus 7. Now, when I factorise that, we can see how this trick is working. I've got a common factor of 7 and factorising here. So Fergus, watching carefully because this is where you got a bit unstuck. 7 watts give me 14n, 7 times 2n plus 1. Okay, so we've shown that 7 is always going to be a factor of the numbers that we had. Right, so you guys have just figured that out. All of them are 7. Yep, you got it. Right, they're all multiples of 7. So let's try another one. And I've got a whole sheet of these for you guys to try, and they're really, really beautiful practice at both expanding and factorising. So we've got this. I want you to tell me, what is this always a multiple of? Okay, so what is that expression? So if you did a think of a number on this, it would be Arthur and Kieran. What are you saying? Oh, I can't see your messages. Oh, they've gone away. Right, so if I did think of a number on this, I'd do my number, I'd double my number, and then I'd take 3 away. And then I'd times that all by 3, and that would be my A, right? And then I'd take that same starting number, I'd double it, and then I'd add 1. And I'd times it all by 5, and that would be my B, and then I'd get my A plus B. So, what is this a multiple of? Right, I want you to take 3 minutes I'm going to give you in your books to do the expanding and the factorising and tell me what's it a multiple of, right? And for speedy finishes, I want you to do a second one in the same time because I know you're out there, and do this one. What is this one always going to be a multiple of? 4. Yep, Roy thinks he's got 4. Okay, Roy, go on and do that next one. Okay, so Roy's seen that it's 4. Arthur's got that it's 4. Yep, cool. Right, Arthur and Roy, keep on going. Do the next one and see what you get. And then what I want you to do is to go to the Google Classroom for the 9 enrichment and go to the task in there that's called expanding. And there are like 2 pages of these things where you have to prove that something is a multiple of something. Okay, and they're really cool questions. Right, well done, Torben. That's great. Okay, second one's not 4. Not going to be 4. I don't think it's going to be 4. Let's see. Yeah, I don't think the second one's 4. Let's do the first one. We'll go through it, and then we're going to stop because I have to get off the computer because my daughter's got a Skype lesson with her flute teacher in about 5 minutes. So, looking at this one, what do we get? Well, we'll get rid of that. Get rid of this. Look how clean it is now. Okay, so here's the expansion. We get equals 6n. Where's my pen gone? Pen's gone. Funny, weird. 6n minus 9 plus 10n plus 6. That gives me 16n minus 9 plus 6. What have I done? 6n minus 9 plus 10n. No, 6n plus 5. That's better. 16n minus 4, which equals 4 times 4n minus 1. So it's a multiple of 4, right? No matter what answer I come up with. Cool. Isn't this cool? I think this is a cool activity. Right, this one, 28n plus 70 minus 18n minus 90 gives me 10